Hello, this is Satyam here. I just wanna assign you a role of like AI/ML interviewer, and you have to ask me the questions, and I will answer. Okay?
Sounds like a plan. So, for your first question, can you tell me when you might use a simple linear regression versus a more complex neural network?
Okay. So I use linear regression when we have like predict to when I have to predict something like continuous data. Okay, when we have a regression problem, and I go with it like when we have a small data. But if I have a like big data, like DL is good for big data. So then I use neural network when I have a like, let's say 1 lakh rows and 10 lakh rows. Then I go with the neural network.
That's a good point about data size. Now, what about computational cost? Which one would be more resource heavy, and why?
Hmm. Of course, DL, because it has a like lots of rows, and if I have a like GPU in our Google Colab, if I have activated, so it might be like less time, or we can take to train our model.
Exactly. Those multiple rows and complex calculations contribute significantly. Now, within a neural network, what part of the process do you think benefits most from that parallel processing you mentioned with GPUs?
Sorry, can you ask again? I didn't got.
No problem. I was wondering, when you mentioned GPUs being better for deep learning, which part of the neural network's training do you think benefits most from that parallel processing they provide?
Okay, so you are asking like when I should use the GPU, like, am I right?
Not quite. You mentioned that GPUs are good when you have a lot of data or complex models. I'm just wondering what makes their design, like having lots of cores, especially useful during training.
Yeah, like when we have a lots of epochs, then we can go with the GPUs.
That's true. More epochs definitely add to the computation time. Could you elaborate on why those multiple passes are usually needed for a neural network to learn? What's happening to the model during that process?
During process, we have a like complex multiplication. We have some filters. We have about 1,000 filters, like not 1,000. We have like 64 filters, 128 filters. We have and they moves over the images and extract the important features, and also they do some calculation. So for that we need GPUs. But if you are like training simply, then you can also go with that. But if you need a faster training your model on a specific data, then you can on your GPUs. So we have a like complex multiplication behind the training, and all there are like lots of mathematics we see.
That's a really good explanation. Focusing on those complex calculations and feature extraction, especially in things like computer vision. So, moving on, can you tell me about a specific project you worked on where you had to choose between a simpler model like regression and something more complex? What were the factors in your decision?
Yeah, I have like make so many projects like heart disease prediction company, and sugar prediction, and car accident probability. There are like so many. But if I tell you, like I have used heart disease prediction, where like I was getting so less accuracy in like logistic regression. And when I have tuned this. When I tune my model, I have used some hyperparameters and all. Then I got like more accuracy. I think I have used random forest, because it is like best for also overfitting, and it also uses the hyperparameters. Then when I apply random forest, then I got more accuracy. And and like it was a generalized model. So I think that model was the best, and we can also go with the neural network where we can also get more accuracy. So yeah, but I have applied random forest.
That's
That's
interesting.
interesting.
So
So
you
you
found
found
that
that
hyperparameter
hyperparameter
tuning
tuning
and
and
moving
moving
to
to
an
an
ensemble
ensemble
model
model
like
like
random
random
forest
forest
improved
improved
your
your
accuracy
accuracy
over
over
logistic
logistic
regression.
regression.
When
When
you
you
chose
chose
random
random
forest,
forest,
were
were
there
there
any
any
specific
specific
aspects of
aspects
the
of the
data
data
or
or
the
the
problem
problem
that
that
made you
made you
favor
favor
that
that
method
method
over a
over a
potential
potential
neural
neural
network?
network?
Even
Even
though
though
you
you
mentioned
mentioned
neural
neural
networks
networks
could
could
also
also
be
be
accurate?
accurate. Yeah, like I go to random forest when we have a overfitting problem, and usually I go with the random forest and XGBoost plus cross validation when I have to take a part in competition. So in a there is a website. I think I forget. So there we can take our like part of the competition. Then we can go with the random forest because it is good for like overfitting. So we can go with it, and it also provides us more accuracy because we have a multiple decision tree. They like every tree is taking their own decision, and then we go with the maximum prediction. So yeah, that's great because it has like entropy and information gain. So that's why I use random forest and XGBoost because XGBoost is like for more accuracy. And then I after XGBoost, after the implementation of XGBoost, I go with the cross validation because XGBoost sometime it might be and overfit. So that's why I go with the cross validation that help us to overcome from the overfitting.
That's a
That's a
really
really
detailed
detailed
breakdown of
breakdown
your
of your
process,
process,
especially how
especially
you
how you
use
use
random
random
forest and
forest and
XGBoost with
XGBoost with
cross
cross
validation to
validation to
manage
manage
overfitting.
overfitting.
It
It
sounds
sounds
like you
like you
have a
have a
strong
strong
strategy
strategy
for
for
those
those
competitive
competitive
scenarios.
scenarios.
For the
For the
next
next
question,
question,
can
can
you
you
explain
explain
in
in
simple
simple
terms
terms
what
what
generalization
generalization
means in
means
the
in the
context of
context of
machine
machine
learning
learning
and
and
why
why
it's
it's
so
so
important?
important? Of course, generalization means it should our model should perform well on the unseen data, and like our model sometime we have a model which is like performing well on the testing data, but sometime sorry, it is like performing better on the training data, but sometimes it fails to perform better on the unseen data testing data. So our like aim is to get the best output from our model. So we sometime our model become overfit, but we want like best thing here, like we have to predict the best thing here. We don't want to our model that it can be overfit. So generalize means we have to like it should our model should perform better on the unseen data. Model should perform better on the unseen data and testing data. That's a generalized model, and it means low bias and low variance.
That's
That's
exactly
exactly
right.
right.
Making
Making
sure the
sure the
model
model
works
works
on
on
data
data
it
it
hasn't
hasn't
seen
seen
before.
before.
Now,
Now,
what
what
causes a
causes a
model to
model to
become
become
overfit,
overfit,
where it
where it
performs
performs
great
great
on
on
training
training
data
data
but
but
poorly
poorly
on
on
testing?
testing?
And
And
how
how
can we
can we
prevent
prevent
that?
that? Oh, our model like sometime it become overfit because I think some of the regions. So, but we can overcome from this. Like we have some technique like cross validation, random forest, and we have a L2 and L1, and we have also what is which is a dropout where some of the random neurons we turn off. So I think that's the best thing for overfitting.
Those
Those
are
are
all
all
effective
effective
techniques,
techniques,
from
from
cross
cross
validation
validation
to
to
regularization
regularization
like
like
L1
L1
and
and
L2,
L2,
and
and
dropout
dropout
for
for
neural
neural
networks.
networks.
It
It
seems
seems
like
like
you've
you've
got
got
a
a
good
good
grasp
grasp
on
on
how
how
to
to
build
build
models
models
that
that
generalize
generalize
well.
well.
So,
So,
for
for
our
our
last
last
question,
question,
how
how
do
do
you
you
stay
stay
updated
updated
on the
on the
latest
latest
research
research
and
and
developments
developments
in
in
the
the
constantly
constantly
changing
changing
field
field
of
of
AI
AI
and
and
machine
machine
learning?
learning? Oh, I have like noticed one thing in AI field that like many technology can come in the future, and now every day new AI model is coming and people is using it. but I think if you have a like strong foundation, and if you have a like a basic knowledge of ML transformers, then you are not going to be like replaced by anyone. So we have to focus on the basic thing where we have to learn ML and transformer, because people is going to learn the new technology. Before people should learn these technologies, and they can learn the new technologies, they can adapt the new technology. But we have to always, person will, in the future, if they learn new technology, then they will, of course, they will go with this scenario like MLDL transformer. So I have noticed this thing, that's why I am also creating some kind of, you can say, strong background in this like MLDL and transformer. Then I can like learn any technology related to the field, like AI, like generative AI, and agent and all.
That
That
makes a
makes a
lot
lot
of
of
sense.
sense.
Prioritizing a
Prioritizing a
strong
strong
foundation
foundation
in
in
the
the
core
core
concept
concept
so
so
you
you
can
can
adapt
adapt
to
to
whatever
whatever
new
new
tools
tools
come
come
out.
out.
Well,
Well,
that
that
were
were
my
my
last
last
questions.
questions.
Thanks
Thanks
for
for
participating
participating
in
in
this
this
interview.
interview.
You
You
demonstrated
demonstrated
good
good
knowledge
knowledge
of
of
different
different
models
models
and the
and the
trade
trade
offs
offs
involved
involved
in
in
choosing
choosing
them.
them. What? Have you asked something?
Oh,
Oh,
no,
no,
I
I
was
was
just
just
letting you
letting you
know
know
that
that
was
was
my
my
last
last
question
question,
and
and
thanking
thanking
you
you
for
for
participating in
participating
the
in the
interview.
interview.
You
You
did a
did a
great
great
job.
job. Yeah, thanks. I was, I just thought that you have asked something, because I was like seeing somewhere, like, okay, because like there are so many people is like near me, they are just going in through and from motion. So I was just seeing them. That's why I didn't focus on your question. So sorry for that. And I think we have to end the session here.
No
No
problem at
problem at
all.
all.
I
I
understand.
understand.
It
It
was
was
great
great
talking
talking
with
with
you,
you,
and
and
bye
bye
for
for
now.
now.
I'll
I'll
end the
end the
session
session
here.
here. Bye bye.